In today's class, we are going to look at a question on confidence interval in statistics. A machine produces a component of a product with a standard deviation of 1.6 meter in length. A random sample of 64 components was selected from the output, and this sample has a mean of 90 centimeter. The customer will reject the component if it is either less than 88 centimeter or more than 92 centimeter. Now the question is, does the 95% confidence interval for the true mean length of all the components produced ensured acceptance by the customer? That is, at 95% confidence interval, will the customer accept the component produced? You understand? That is, will the customer accept the mean length of the component produced? You understand? Please, I want to note the parameters that we are given in the question, okay? Let's start by writing out the parameters that we are given in the question. We are given that the standard deviation that is SD, standard deviation is equals to 1.6 centimeter. And the sample component, the sample component is equals to, let me just put it, sample component is equals to 64. Please, I want you to pay attention, okay? And the mean length of the sample mean length is equals to 90. That is 90 centimeter. The range at which the sample will be accepted is between, let me just put it, range. Please, I want you to pay attention, okay? The range is 88 centimeter. That is, the sample must not be less than 88 centimeter and must not be greater than 92 centimeter. Now, the question now says we should determine whether 95% confidence interval for the true mean length of all the components ensure acceptance by the customer. See, I want you to pay attention, okay? Look, the customer said that the range should not be less than 88 centimeter and it must be between this range. You understand? The component must not be less than 88 centimeter and it must not be greater than 92 centimeter. Please, the first step in solving this question is to remember your formula, okay? The first step in solving this question is that just remember your formula. The formula of confidence interval is given by this: mean minus z alpha 2 multiplied by this over n. Don't worry, I'm going to tell you all the parameters that we have in this formula. Do you understand? Don't worry yourself. I'm going to tell you all the parameters that we have. Just pay attention. Less than this, less than x bar plus z alpha over 2 multiplied by over n. No, over root of n. This is root of n, okay? This is over root of n. Please, I want you to pay attention. We have x bar. X bar is the mean, okay? I want you to note this. X bar is the mean. Now, do you know the meaning of this? This is the critical value. You understand? Hello? This is the critical value. We are going to get this value from our standard distribution table. Do you understand? This, you see, this is the formula to determine the confidence interval. You understand? We want to check whether the range will lie between this range or it will not. You understand? Maybe the customer will accept it or he will reject it. You understand? But we cannot determine it without using this formula. So I'm telling you the parameters that we have in this formula. You see, this x bar is the mean that we are given in the question, okay? And this z alpha 2 is the critical value. We are going to get the critical value from our standard distribution table. You see this one that look like 6 is not 6, so it is standard deviation, okay? The standard deviation of the component. Do you understand? The standard deviation of the component, that is what we call this, okay? And the n is the total numbers of sample. The numbers of sample that we use, that is what we call, that is the value of n. Are you paying attention? And this U, this one that look like U, is what we call the main length of the population component. You know, we have many population. We only sampled some of the population out. Hello, just like maybe you want to compute a research on thousands of students, how on the performance of thousands of students. You can choose out of 1,000 of students, out of 1,000 of students, you can choose to use 800 among them. You understand? That is what we call your sample. Okay, hello, pay attention. Let's say you want to conduct a project research on the grade of students, and the total numbers of population of students in that area is 1,000. Are you paying attention? Then you might choose 800 out of those 1,000 students. That 800 is what we call the sampled population. The total numbers of students is what we represent as this. Do you understand? That is the total, the main length of the population. Do you understand? Now, this is also X bar. That is the main, and this is the standard critical value. The critical value, we are going to use our standard distribution table to determine the critical value, and this is the standard deviation, and N is the total numbers of population sample. Okay, that is the sampled population, not total population now, sampled population. Okay, now how do we solve this? You see, this formula that you see here can be we can write it as this: X bar minus Z alpha 2 multiplied by SE less than or equals to the population mean length less than or equals to the mean plus the critical value, that is at 2 tail, multiplied by SE. There is no difference between this formula and this formula. They are the same. Okay, this formula and this formula are the same. From your basic statistic, standard error, SE is what we call standard error. Okay, SE is what I call standard error. Standard error is equals to standard deviation all over the root of the numbers of sample. Okay, do you understand? Standard error is equals to standard deviation all over the root of the total numbers that we sampled. Okay, now let us start by calculating our standard error. You understand? Don't forget that we've been given that the standard deviation is what? 1.6. So for this, I'm going to have 1.6, which is the standard deviation, all over the square root of the total numbers of the total numbers that we sampled is 64. Okay, sampled components. I didn't write it in full, but when you are doing this in the exam, write it in full. Okay, sampled component is the n. Okay, so all over 60. 1.6 all over the root of 60. The square root of 60, oh, it's not 60, sorry. This should be 64. 1.6 divided by root of 64, that is 1.6 all over 8. So if you punch your calculator, you're going to get 0.2, okay? So the value of this is 0.2. Now we have determined the standard error. Now we've gotten our standard error as 0.2. So we have all the parameters in this confidence interval formula except the critical value. Now I want to teach you how to determine your critical value. To get your critical value, don't forget that I told you you're going to get your critical value from the standard distribution table. You understand? You see, this test is two-tailed test. Hello, this test that we are doing is two-tailed test. The reason is this is how I figured it out, because I have range. You understand? The customer does not want a length that is less than 88 centimeter, and the length should not be greater than what? 92 centimeter. So it is a two-tailed test. Okay, assuming we have only one-tailed, that will be either maybe the right-tailed or the left-tailed, but in this case we have the range. The customer who doesn't want the length of the component should be greater than 92 and less than 88. You understand? So this is the two-tailed test. Now, this is the standard distribution table that we are going to use to determine our critical value. Don't forget that we are dealing with two-tailed test. You understand? We are dealing with two-tailed test, and we are given in the question that we should test for 95% confidence interval. But on this table, we don't have 95%. We only have 1%, 2%, 5%, and 10%. Now, how do we determine our 95%? Just subtract 95 from 100, okay? If you subtract 95 from 100, you are going to get what? 5. You understand? So we are going to look at two-tail test under 5%. Do you understand? You are going to check two-tail test under 5%. Do you understand? And if you look at this table, the two-tail test under 5% is what? 1.96. So our critical value is 1.96. Do you understand how I got it? So the critical value is 1.96. Do you understand? So please, anytime you come across question like this, you get your critical value from your standard distribution table, and most of the time they might give you in the exam. You understand? But it is very, very important that you know it. Okay, it's very, very important that you know it. So now let us proceed. We have gotten all the parameters that we need in this formula, so we can proceed to plug in all our value. Now don't forget that mean is what? The mean is 90. So I'm going to have 90. Oh, let me change the marker. So I'm going to have 90 minus the critical value. The critical value is what? 1.96. 1.96 multiplied by standard error. Standard error is what? Standard error is 0.2. So I'm going to have multiply 0.2 less than or equals to this. Or you can put less than or equals to the mean value. Oh, sorry. The mean value is 90. So just substitute 90 plus the product of the critical value, which is 1.96, multiplied by the standard error. The standard error is 0.2. So for this, I'm going to have 90 minus 1.96 multiplied by 0.2. That is 0.392. 0.392 less than or equals to the mean of the population, less than or equals to 90 plus 0.392. Okay, now 90 minus 0.392, that is 89.608. This is 89.608 less than or equals to this. So 90 plus this, I'm going to have 90.392. Do you understand? So you can leave your answer like this or approximate to 2 decimal places, but I prefer to approximate. So for this, I'm going to have approximate 89.608 to 2 decimal places. We are going to have 89. Oh, let me change the marker, please. I'm going to have 89.61. You understand? Or equals to 90.39. So this is the confidence interval. Now I want you to pay attention. We have gotten the confidence interval as this. Now how do we interpret this question? Don't forget that the question says, does 95% confidence interval for the main length of all the components ensure acceptance by the customer? Do you know the meaning of that statement? That is, with the customer accept the main length at 95% confidence interval. Don't forget that the range which the customer wants is between 88 centimeter and 92 centimeter. Hello, pay attention. The range which the customer demand is between 88 centimeter and 92 centimeter, but we have 89.61 centimeter and 90.39 centimeter. Now we want to check whether the customer will accept it or not. The customer is going to accept the main length at 95% confidence interval because the range lies between the range that the customer wants. Okay, don't forget, in the question, the question stated that the range that the customer wants is between 88 centimeter and 92 centimeter. Now after testing for the 95% confidence interval, we got 89.61 centimeter, which is greater than what? 88 centimeter, and we got 90.39 centimeter, which is less than what? 92 centimeter. So it is the confidence interval at 95% falls within the range that the customer wants. Therefore the customer is going to accept the main length. Now how do you interpret the question? You just have to put it like this. This implies that the true value of the population mean length will fall between 89.61 and 90.39. Therefore, 95% confidence interval ensure acceptance of the component by the customer. You understand? The customer will accept the component because the 95% confidence interval falls within the range that the customer wants. Do you understand? So that's it. See you in the next class. To watch more video on confidence interval, check the link in the description of this video. Click on that link to watch other example. Okay.